Okay, so again class, please take note of our formula for the percent purity, ha? Percent purity is equal to normality times the volume. This is for the titrant times the milli-equivalent weight of the sample. Again, this is for the sample. And then divided by weight of the sample times 100. But we will only use this formula if the titration is direct. Okay, we have a different formula for the residual or indirect titration. But before we'll discuss the indirect titration, let's have first this last problem. We have here 20 sodium salicylate tablets labeled 325 milligrams were dispensed in sufficient water to make 200 ml. A 15 ml aliqua of the filtrate was titrated to a bromophenol blue endpoint in the usual way by 29.11 ml of 0.1 normal hydrochloric acid. So calculate the amount in percent of sodium salicylate. The equivalent weight for the sodium salicylate is 160.11. Now, since we are done discussing the other problems, let me see if you can still remember how to do the math. You first try to solve there in any sheet of paper and then kindly send your answers. It doesn't matter if it's right or wrong. Kindly send it via direct message here in the chat box. And then I will be recording that for your participation this afternoon. Okay? Try nyo muna kung makuha nyo ba siya. And then we'll answer later sa screen. Bibigay ko kung paano siya sasagutan. Apa? I'll wait. I'll wait. Ano, may question mark. Okay. About yung iba? Nalibog. Wala na. Last na na. Tinakabok. 1, 2, 3, 4, 5, 6. Ay, wait. Sige. Makatawa kasi yung mga ginasend. Dahil kay question mark. Apil na siya sa answer. Ay, nabalhin. Sorry. Okay na. Nilahi mo answer. Wala, nagkapareho answer, no? Dito sa kaani ang tama. Sige, let us answer the screen. Well, let's see kung kinsaan tama and para alam ng lahat kung ano yung gagawin with this type of problem. I actually took this problem from an exam. I did not make this problem, ha. I took this sa isang exam I encountered during the review days. Definitely, this is not coming from the board exam, but the board exam also has this kind of question. Sa area 6 kasi QC is under the area 6. This will be the last exam for the board exam. Ano siya, 2 hours. 2 hours ba siya? I think so. It's 2 hours because of the computation. Sige. So what are we looking here is the percent purity, the amount in percent. We are talking about percent purity here. And for the percent purity, our formula is, dito na lang po, N times V times MEQ weight divided by the weight of our sample times 100. So again, what we are looking here is the percent purity. For the other given, the normality, I told you a while ago that the N and the V are for the titrant. So looking at the problem, the titrant here is the hydrochloric acid. So you have here the normality, which is 0.1000 in ml. So I'll be using I'll be using MEQ per ml so that I can again easily cancel the unit. Times the volume. The volume used during titration is 29.11 ml. Times the milli-equivalent weight. Again, the milli-equivalent weight is for the sample. So what is our sample here? Sodium salicylate, but, okay. Equivalent weight pala yung given. Okay, I'll be changing the units, ha? I'll be changing the units. Again, no need to compute for the equivalent or the milli-equivalent weight because it is already given in the problem. So, ang nakalagay, equivalent weight, ha? Pag equivalent weight, that is, this should be grams per equivalent. So, ano yung sabi ko na i-change ko ang unit? I-change ko ang units, class, kasi ang partner ng equivalent weight is liter. Okay? Liter. So, I'll be changing this. This will become equivalent per liter. And I'll erase this one since I'll be doing the conversion. 29.11 ml times sa isang litro, meron tayong 1,000 ml. Cancel this. 29.11 divided by 1,000 is 0.02911. 0.02911 liters. Okay? Ito yung gagamitin ko here. 911 liters. Now, sa baba, this is times 100. Sa baba, class, this should be the weight of the sample. Ano kaya yung weight of the sample here? Let's analyze the problem. Meron tayong 20 na tablets, 20 tabs. Each of them weighed 325 milligrams. Okay? So lahat yan, winay and nilagay sa tubig. Okay? So, ang mangyayari, ito 200 ml. Okay. So, ganito yung mangyayari. Kukunin natin yung weight ng lahat ng tablet dyan na na ginamit. So 20 tablets times yung labeled amount ng sodium salicylate is 325 milligrams. So this is 6,500 milligrams na nilagay sa 200 ml. Pero hindi natin gagamitin sa 325 milligrams kasi that is just for one tablet. Pero ang nilagay kasi dito lahat ng 20 tablets nilagay sa water. Pero during titration kasi hindi din the whole 200 ml ang ginamit. Nakita niyo dito, alikwat, we have here the portion only, meaning 15 ml lang out from the solution na ginawa yung ginamit during titration. So hindi mo din pwedeng gamitin ang buong 6,500 milligrams. So dito papasok si PharmCal, we will have ratio and proportion. 15 ml lang yung ginamit. So sa 15 ml, ilan kaya yung sodium salicylate dyan. So 6,500 times 15, you know ratio and proportion, right? Let's do the cross multiplication. So again, 6,500 milligrams times 15. That's 97. I have limited space. Right place. Dito na lang talaga. Let's just make a division. Okay, so this becomes now 200 ml x equals 6,500 times 15 is 97,500 milligrams divided by 200 ml. This is milligrams ml. Okay, cancel the ml, cancel this one. Ang ginamit lang during titration is 487.5 milligrams. But take note that in the computation of the percent purity, kailangan nakagrams yan siya. So we are not yet done. We can convert this one milligrams. 487.5 milligrams times sa isang grams, meron tayong 1,000 milligrams. So this is equal to 0.4875 grams. So yan yung gagamitin natin here for 0.4875 grams. Now we can cancel units and do the math. Liters, equivalent, and grams. So walang matitira dyan. Now 0.1 times 0.02911 times 160.11 is 0.46608021 divided by 0.4875 times 100. The answer 95 point. I'll just round it off to 2 decimal places. So we have here 95.61%. Again, this one is the correct answer for this type of problem. Kinsay nakatama? Wala nakatama. Wala nakatama. So, alin dyan yung part sa solution ang hindi nyo nakuha? Volume of grams. Okay. How about the others? Taba. Ganito yung mga questions sa board exam class. You really need to understand the problem first before you do the math. Because I believe you are very familiar with the formula. It's just that May mga bagay na you really have to consider. So just like this one, okay lang si normality, no? And si volume class, bakit ako? Okay, let's give emphasis to this. Bakit ako nag-convert? Kasi yung given is equivalent weight. Again, ang partner ni equivalent weight ay liters. We will just use ml if we are going to use the milli-equivalent weight. So I should have edit this pala. This should be equivalent weight. Kasi in equivalent weight, so again, ang partner niya is in liters. Kaya ako nag-convert. So itong unit ng normality, we can always adjust the unit. The same lang yung number. Magbabago lang siya. Instead of MEQ per ml, pwede mo din gamitin ang equivalent per liter kasi ano naman sila, equal naman sila sa capital letter N. And then, yung weight ng sample. So ito talaga yung pinakamataas, mahaba yung process. Hindi mo basta-bastang pwede gamitin si 325 milligrams. You have to be mindful you really have to be alert when it comes to the problem. Kasi kung titingnan mo ang problem, hindi naman talaga siya ginamit. Ang ginamit na na sample in the problem is just 15 ml. So kukunin mo muna kung ilang sodium salicylate yung nandyan sa 15 ml na yan. So balikan mo yung first sentence. Meron ka daw 20 tablets. Each of them is labeled 325 milligrams. Kaya ako siya minultiply. Kasi lahat ng yun nilagay kasi dito sa 200 ml na solution. So out from the 200 ml, 15 ml lang again yung ginamit sa titration. Pero pwede din po siya, ma'am, na i-convert sa ito. Yung equivalent weight. Yung equivalent weight, you can convert this to MEQ also just by dividing 1,000. Divide mo yung 160.11 sa 1,000, magiging MEQ weight na yan siya. And you are no longer required to convert the volume in ml. Mag-assist na siya na ml as long as partner silang dalawa ng milli-equivalent weight. Okay, do you have questions about the direct titration? Oh, diretso. No need to look for the F. No need to look for the F here. Ano sabi mo? Hindi na. No need na. Kung i-convert mo, equivalent weight to MEQ, no need na for the F. You just divide the equivalent weight sa 1,000. Kasi yung F, nasama naman na siya doon sa pag-compute ng equivalent weight. Pero kung talagang magsa-start ka from scratch, yung sa molar mass ka talaga magsa-start, that's the time you use this formula. Okay? Start ka from scratch. Ito kasi equivalent weight yung given. So, diretso siya, divide 1,000. Kung i-convert mo. Okay? This is for the conversion. Ito yung, you will really start from the molar mass. You really need the F or the equivalence factor. Okay? Anything else na hindi naintindihan dito? There will be instances in the laboratory class na hindi man gura ko ang teacher nyo sa lab, no? Pero if ever lang, and I don't think I still have laboratory classes sa inyo, ha? But anyway, sa laboratory kasi minsan may mga instances na you will be looking for a certain chemical with a certain percent purity or certain concentration. And I will really ask you to do the math. How are you going to prepare that chemical? So you have to be mindful of the formula and how to do it. Work din natin yan as pharmacist, mag-prepare ng chemicals minsan sa laboratory. Now, if you don't have questions anymore about the direct titration acidimetry, let us move forward to our residual. titration. Acidimetry pa rin ha. So our sample here is an alkaline or a base. And then since this is residual, so we have 2 titrants. Okay, so the other one is added in excess, and that is for the acid. And then the excess will be titrated with another base. Thus, our formula, percent purity is equal to normality times volume of the acid minus normality times volume of the base. So we have again 2 titrants here. Or we can just simply have normality times volume of the first titrant minus normality times volume of the second titrant times the milli-equivalent weight gihapon divided by weight of the sample times 100. So the same process ng pag-compute of the percent purity, it's just that since we have 2 titrants, we also have 2 normality and 2 volume. So for the example, we have here if a 1.25 grams sample of zinc oxide were titrated with 50 ml 1.1230 normal sulfuric acid, that's the first titrant, and required 27.48 ml of 0.9765 normal sodium hydroxide in the back titration. Back titration is synonymous to indirect or residual titration. So what is the purity of zinc oxide? Let's just use this one since nabigay na siya dito. Most of the time yung instructions ko kasi sa mga quizzes and sa exam, the atomic weights should be rounded off to the nearest whole number. So sa mga quizzes and sa exam lang yun ha. Pero you have to follow instruction pa rin. So read the instructions carefully. This time, since nabigay naman na yung molecular weight ni zinc oxide, we don't need to compute for it anymore. Gamitin na natin siya agad. Okay, so we have again, what was our formula? Percent purity is equal to the normality times the volume of the first titrant minus the normality times the volume of the second titrant times the milli-equivalent weight. Again, this is for the sample divided by the weight of the sample times 100. So our first titrant here is this one. Again, para hindi kayo malito, kung anong una dyan, ano yung A, ano yung B, sa acidimetry, the first titrant is an acid. And as you can see, indeed, sulfuric acid is an acid. And then the second titrant is a base. And yes, we have here the sodium hydroxide. Do not forget that. So for the first titrant, the normality is 1.1230 normal. Let me just use, this is milli-equivalent weight, okay. So let me just use MEQ per ml times the volume. What's the volume? 50 ml for the sulfuric acid minus the second titrant. We have here 0.9765 MEQ per ml times what is the volume? 27.48 ml times the milli-equivalent weight. We don't have the milli-equivalent weight here. We need to compute for it first. So milli-equivalent weight is equal to the molar mass over F times 1,000. So our molar mass is already given. Molar mass is also the molecular weight. So we have 81.41 grams per mole divided by the F. So what will be the F of zinc oxide? Let me see if you can still remember how to get the F. Two, very good. It's 2. 2. 2 dapat siya. Bakit siya 2? Pa-check, bakit 2? Saan sa periodic table si zinc? Nasa transition metal. Nasa gitna. So, most of the transition metals class ang charge neto positive 2. And then si oxygen nasa group 6 and ang charge ng ating oxygen is negative 2. So both of them plus 2. Kaya ang F natin ay 2 times 1,000. Our unit here is MEQ per mole. So, cancel the mole. Ano na? 81.41 divided by 2,000 is 0.040705 grams per MEQ. So, ito yung gagamitan natin here. 0.040705. I'm not really fond of what do you mean that? Rounding off numbers kapag hindi pa siya final answer. 0.040705 grams per MEQ divided by the weight of the sample, this one, 1.25 grams. Do not forget that times 100. Basig makalimtan. Okay, so let's do the math. 1.1230 times 5, 50, I did it 5. Times 50 is 56.15, cancel the ml. This is in MEQ minus 0.9765 times 27.48. Cancel the ml also. So, ang maiiwan MEQ. 0.9765 i-copy na ko. Naraday sa calcu. Sa calcu, day dapat ko ng tanaw. 26.83422 MEQ times the 0.040705 grams per MEQ divided by 1.25 grams. We can cancel the grams times 100. Actually, we can cancel the MEQ. Dalawa yan sila, pero ima-minus mo kasi, di ba? So, magiging isa na sila later. What do I mean by magiging isa? 56.15 minus 26.83422 is 29.31578 MEQ. Yan yung sinasabi ko. MEQ na siya, kaya kinancel ko na siya kanina. Okay? So, pwede ko na yan siyang tanggalin. Times 0.040705. Wala na tayong unit na natira. Times 100. Dito na lang yung continuation. 29.31578 times 0.040705 is 1.1932.98825 divided by 1.25 times 100. The percent purity of zinc oxide here is 95.46%. Okay, so that's how you do the computation for the percent purity of a substance that is standardized using residual or indirect titration. Medyo mahaba, but just please be patient. Okay? And then review your solution if tama ba talaga ang ginawa ninyo. Tell me if it's okay to delete the writings on the screen na, ha? Okay na? Delete ko na. Ay, saan na to? Okay. Sige, kayo naman. Delete. Asan na ang delete? Sige daw, you try. You try solving this one. 50 ml of 0.1 and silver nitrate BS was delivered in the assay of sodium chloride. Actually, this is not acidimetry. This is not acid and base. But anyway, for the sake of the residual titration, since they have the same formula and way of computing for the percent purity, let's just answer this. So again, 50 ml of 0.1 and silver nitrate VS was delivered in the assay of sodium chloride. The molecular weight of sodium chloride is 58. The back titration involved 12 ml of 0.1 and ammonium thiocyanate VS. VS is volumetric solution. Basig matingala mo. Or basig nakalimot na mo. So if the sample weighs 0.1234 grams, what is the percent purity? Sige, try nyo i-solve using our formula for the back titration. Send pa rin sa ano ha, direct message sa chat box ang answer niyo. Let me record first those who answered last time. Delete na po. Screenshot ko na lang para mas madali. Ay, sa phone na lang. Ay. Ako di ay. Ano? Sensitivity. Okay. Wala na, last na na eh. Kaya magsugod na tawag check. Okay. Let's check if tama yung answer. Parehas na pong answer tanan. Okay. So, the same formula, percent purity is equal to N times V of the first titrant minus N times V of of the second titrant times the milli-equivalent weight divided by weight of the sample. This should be in grams times 100. Now, looking at the problem, baliktad kasi yung problem, yung sample nandito sa baba. This is the weight of the sample. We are looking for the percent purity, and thus yung nasa taas will be the first and the second titrant. So this is the first titrant here, 50 ml of the 0.1 normal silver nitrate. And ano yung kanyang normality? 0.1. So this is 0.1 MEQ per ml times the volume is 50, that's 50 ml minus the second titrant is 12 ml and still 0.1. So 0.1 MEQ per ml. As you can see, there is the here the hint. Pag sinabing back titration na, that's the second titrant na. And then the volume used is 12 ml. And then the weight of the sample, diretso tayo sa weight of the sample kasi given na siya automatically 0.1, 2, 3, 4 grams. Sorry, I forgot the milli-equivalent weight. The milli-equivalent weight, what is our sample? Assay of sodium chloride. Okay, so the assay of sodium chloride, which means that the sample here is the sodium chloride. So how do you get the MEQ of the sodium chloride? Molar mass divided by F times 1,000. So it's already given 58 grams per mole divided by the F for NaCl. This is positive 1, this is negative 1. So this is just 1. Times 1,000 and then MEQ per mole. Cancel the mole. Our milli-equivalent weight here is, i-calculate pa dyan, no? Nitrous tissues. 0.058 grams per MEQ. So ayan yung ating milli-equivalent weight. 0.058 grams per MEQ. So do not forget the times 100. Dito ako sa baba magpatuloy ha. 0.1 times 50 is 5. MEQ na lang yung maiwan. Cancel the ML. 0.1 times 12 is 1.2 MEQ. And then times 0.058 grams per milli-equivalent divided by 0.1234 grams times 100. So 5 minus 1.2 is 3.8 MEQ times the 0.058 grams per MEQ divided by 0.1234 grams times 100. Cancel the MEQ, cancel the grams also. Let me continue here on the right side. 3.8 times 0.058 is 0.2204 divided by 0.1234 times 100 is, what's the percent purity? Okay, tama. Percent purity is equal to 178.61%. So this is the correct answer. And yes, most of you got the correct answer. Yung hindi nakakuha ng 178.61, ano nangyari dyan? 178.61. Walang negative na answer sa percent purity ha. Pag nag-negative ang answer nyo, that should give you class a hint na your answer is wrong. Okay. Libat ka sa 5. Asang 5? Okay, ayaw ibaliktad. Pag nalibog mo unsa ang A, unsa ang B, just Just don't forget na wala dapat negative na answer. So, ikambyo na. Okay? Actually, wala siya kung giingon kagay na this is not actually acidimetry. Nasago lang ni siya nga problem din kasi silver nitrate is not an acid nor a base. So, ano lang siya for the sake of computing residual titration, pinush ko na lang talaga siya. Okay. Ganito din kasi yung formula natin for the other type of residual titration, even if it is not between acid and bases. As long as it's residual titration, ganito pa rin siya. So kung nalito na kayo saan yung uunahin nyo between the two titrant, just remember, wala dapat negative na answer. So kung nag-negative ang answer nyo, baliktarin nyo, okay? Baliktarin nyo. Para dili ta maglibog. Sige. Okay, now we have here nitrogen determination by Kjeldahl method. Again, the process is called Kjeldahl method in the laboratory. This is through titration pa rin, but our goal is to determine the amount of nitrogen in a given sample. So when you say kasi nitrogen, it's all over the environment sa atuang ginakaon, present si nitrogen, especially sa protein, di ba? In your biochem, you learned that yung ating protein is abbreviated as CHON, N being the nitrogen. So kahit sa kinakain natin, we have nitrogen. Now in the laboratory, if we are going to check kung how much nitrogen is present, we can digest the sample with sulfuric acid until there will be decomposition, and then the decomposition should be complete for the sample. Any sample, may it be food or anything, any substance that you suspect na merong nitrogen. And then after the decomposition, actually ammonia is being released, and the released ammonia will be treated with excess sulfuric acid, and then afterwards sodium hydroxide. So bali mahuhulog itong determination of nitrogen as residual titration. And to be exact, this is still under acidimetry sa residual titration because nitrogen class, remember, yung ating mga amines, yung ating though amides is not a base, pero yung mostly mga amines natin are considered alkaline or basic. So kung siya yung sample natin, like si ammonia, acidimetry talaga yon. We will be titrating it using an acid. Kaya nasali dito si Kjeldahl method. Now I told you that the sample before the titration process should be digested first, and ito yung pwedeng gamitin for the digestion or the decomposition. You have their ammonia with sulfuric acid, and then dadagdagan natin to catalyst ito kasi magsispeed up ng reaction, either potassium sulfate, selenium, or copper sulfate. So ito yung example of a problem involving determination of nitrogen using the Kjeldahl method. So we have here the ammonia from a 6.15 grams sample of an organic nitrogen compound was distilled into 50 ml of 0.1246 normal sulfuric acid, and the mixture was titrated with 22.42 ml of 0.0962 normal sodium hydroxide. So calculate daw the percentage of nitrogen in the sample. Sige daw. Please follow kasi the same formula, the same way of computation with that of the residual titration. You try to solve kung gaano karaming nitrogen ang present sa sample na ito. And then the same thing, let's have the participation. You send your answers sa chat box. Yeah, same formula. Okay lang. Let's wait for the others para may participation din sila. No oras na. 3:20. Okay. Ano may huhu? Kasi dapat ang part na dili mo sigurado. Siguradoon. Sige daw. The same formula tayo ha. So we have percent purity is equal to N times V of the first one minus N times B of the second titrant times the milli equivalent weight. Nahin natin ito. Divided by weight of the sample times 100. So our first titrant is syempre the acid. So you have here 0.1246 MEQ per ml times the volume, it's 50 ml, minus the second titrant is the sodium hydroxide. So we have here 0.0962, yes. MEQ per ml times the volume. Hindi mo sa isulat sa kadaghan sa number sa world. Times the volume 22.42 ml. Okay, it's the first part times the milli-equivalent weight. So what is the milli-equivalent weight? This is for nitrogen alone, ha? Nitrogen alone. We are just computing for the nitrogen. So the nitrogen here, molar mass or atomic weight is 14 grams per mole. And saan banda sa periodic table si nitrogen? Nasa group 5. And ang charge niyan ay -3. So this is 3 times 1,000. Equivalent per mole. Ay, milli-equivalent di ay. Cancel the mole. So 14 divided by 3,000. 4.666. Masyadong mahaba. This is continuous. 1, 2, 3, 4, 5, 6, 7, 8. Times 10 raised to the power of -3 grams per MEQ. So, ito yung ilalagay natin dito. And then divided by the weight of the sample is 6.15 grams. Okay? May na-mention dyan na ammonia ha kasi when you digest the sample, pag meron siyang nitrogen, nagre-release siya ng ammonia. But nevertheless, the weight of the sample is 6.15 grams. So again, do not forget the times 100. So let's see. Cancel the ml. We can cancel actually the MEQ. Let's just cancel everything. And also the grams. Para diretso-diretso tayo. 0.1246 times 50 is 6.23 minus 0.0962 times 22.42 is 1.56804 times the 4.6 times 10 the power of -3 divided by 6.15. Do not forget the times 100. I-ano ko ito ha, hindi ko na siya i-step by step. Idiretso ko siya sa calculator. 6.23 minus 2.15, 6804. That's 4.073196 times sa baas mo 4.6666667 times 10 raised to the power of -3. Okay? And then divided by 6.15 times 100. The correct answer, ang percent purity, yung amount ng nitrogen in our sample class is just 0.31%. So, konti lang yung nitrogen natin sa sample natin. Again, 0.31. This is already rounded off to 2 decimal places. Murag gaulan ako mga na siguro nagpaayo na naggabarina actually. 0.31. Yan naman iduha ang answer. Asa lagi ka na 66.01%. I-check ninyo asa na part mo na mali sa ato ang process. Anong wala ninyo nakuha ang 0.31%. Yung iba lang na hindi nakakuha. You may copy. If you want to copy, I'll give you time. Then tell me if okay na. Oh yeah, oo. Apil. Times 10 raised to the power of negative 3. You do the rounding off sa final answer na. Change man dyan, basta mag-convert na ta. Ano siya ang ako instruction permi sa final answer na mag-round off. Kaya pag during the process, kadaghan na ka na times nag-round off during the process, may gahilahin na akong answers tanan anak. Okay, so let me delete now the writings on the screen. Let me check if I still. That's the last slide. Okay, that's the last slide. Any question about acidimetry? Our next lesson will be alkalimetry. I still have time, so I think I'll be discussing alkalimetry also. Clear ko na ito, ha? Any question about acidimetry? Wala.